This lesson's topic is series discounts. There are two objectives: to calculate the series discounts and net prices, and use Excel to do the series discounts. So, vocabulary, we have a vocabulary here. Our vocabulary says that a discount series, also called a chain discount or a series discount or a trade discount series, occurs when multiple discounts are offered on the same item. Discount series are typically indicated with a series of numbers separated by slashes. So a notation example would be 5%, 10%, 5%, or 5/10/5. Both of these represent a 5% reduction from the list price, a 10% reduction on the remainder of the first discount after the first discount has been subtracted, and another 5% reduction on the remainder after the second discount has been subtracted. So we can calculate each one of them one at a time, which is, there's three methods to do that. That's the first method we're going to work on. So if I look at each of them, I'm going to use a complement each time because I think complements are faster. So here's 20%. Remember, the complement is 100% minus the discount percent. So I'm going to take my 80%. And what I'm really finding here is the amount that I will pay, not how much I'm not going to pay, but how much I will pay. So when I take my 80% and I multiply it by $7.95, that's going to give me $636. Then I'm going to do the complement of this one, which is going to be 90%. So now I'm going to get a 10% discount on this, which means I'm going to pay 90% of that price. So 90% of this is going to give me $572.40. Then I have a 5% discount on that amount. That's what this 5% does. So that's going to be that I'm going to pay 95% of the amount instead of the whole amount. I'm going to multiply that by the amount that I just had. And that is going to give me $543.70. That's a 78 cents. Okay, so using the complements, I'm finding out how much I'm going to pay each time after the discount. Over here, I'm going to calculate a single discount equivalent, which means I'm going to find one number to multiply by. So the big error with discounts is people want to take them and add them all up. So 20 and 10 and 5 and say, I have a 35% discount. But I didn't get 35% off of this. I got some off of this, some off of this, and some off of this amount. So it's not really 35%. So I'm not really paying 65%. It's close, but it's not accurate. So instead, we're going to find a single discount equivalent using a complement. So I'm going to take all of these written as decimal form. So 80% is 0.8, 90% is 0.9, and 95% is 0.95. And I'm going to multiply them all together. When I do that, I get 0.684. So if I want to know how much the single equivalent is, I would subtract that from 1, which equals 0.316, which is approximately a 32% discount on everything, as opposed to the 35 we got by adding it up. So it does make a difference. So just be careful. Instead of using this and subtracting it, which is one of the things they want you to do, I'm going to just take this a number like I did over here, and I'm going to use the complement, the 0.684, right? And I'm going to multiply it by the $795. When I do that, I get $543.78. So I think this is the fastest method to do this process. The next thing that you could do is use what's called a table of net price equivalents for single series discounts. And so to do that, there's our table. I'm going to go back and identify where all the pieces are. So my 20% discount here shows up here in my table. And my 10% discount here shows up here in my table. And then my 5% discount shows up here in my table, which is how I end up in this column and this row that's highlighted. And this is my net price equivalent, which I'd already found. Remember in the previous problem I had 0.684. So now I'm going to multiply that by the $795, and that's going to give me $543.78. So, just be cautious. Remember, don't add those numbers together. Common error, never add the percents together first. That doesn't work. We always change them to decimals and then multiply them. Okay, so now we're going to do another problem. My next example problem says that I have a man's shirt that's $60. The shirt price is 20% off with an additional 33% taken at the register. So starting with the $60, right, I could do that and then take the 20% and then the 33%, which was with the first method. Or I can take the complements. So the complement of this is 80% or 0.8. And the complement of this is 67% or 0.67, and I multiply those two numbers together, and that's going to give me 4288.4288. I'm going to actually pay this much of that amount. So this is actually approximately 43%, for lack of a better description. So I'm going to pay 43% of the $60. So I'm going to take the $60, I'm going to multiply it by this in its decimal form, and that's going to give me sorry, there's a couple of errors. Let me correct them. So the 50 times 67, the 80% times the 67 is not 42. It is 0.536. So this is 0.536, which is about 54%. So I'm going to take the $60 and I'm going to multiply it by 0.536, and that's going to give me $32.16. So that's how you do the problems manually. Now let's look at doing these problems using Excel. And I'm going to just walk you through this process. Okay, so the first step is you're going to take your discount and you're going to type it in here. This has a discount of 2010. So this is 20%. The second discount is the 10%. On the CD player list price of $129.40. So the net price equivalent is found by taking the complement of each of these and multiplying them together. Then I can find the single discount equivalent. Then I can find the discount. Well, the discount is actually that the original price times the single discount equivalent. And then the net price is the original price minus the discount. If you have anything else you have to add into these, you would add it after you discount, because some things aren't discounted. Okay, that's the process for doing these series discounts. If you have any questions, pop into a Zoom. I hope everything's going well with you.